Hi, welcome to another video on my Arduino Mega2560 with electronics, pulse width modulation motors, about pulse width modulation, and last time I activated the motors again by replacing the capacitors by resistors, and also checking the voltages and frequencies in the rest of the circuit. It is slowly going the right way. The only thing that does not run yet again is this motor, so I'm still trying to get it running. And unfortunately this is meeting with some problems, and unclear is which problems they are. As you can see, this wire is coming from this transistor, which I can push down, although I have to be careful that I don't break the connectors or the wires. And I can of course measure the voltages. So let me do that, and let's put the black probe for the ground here and measure here, and that is 4,6. And now it is better to show the display as well, so that you can see what I'm measuring. Anyway, this is 4,6, 4,7. Here it is 4,7. And on the last thing it is 0, which is logical because it is connected to mass, so of course that is 0. Then for this it should be 0 as well. However, for this point it is 4.7. Then last but not least, measuring here, also 4.7. So the question is, why is this motor not running? What I can do is taking for instance this motor and replace it and see if this motor runs. So let's do that. Let's stop this one. Oops. Then take off this motor for now and put this one in its place. If the motor is correct, it should run, and run fast. And it doesn't. So let me check on the motor. and I can easily do it like this. If the spindle is going to, that spindle doesn't do anything, so that may be the reason. If this motor is broken, then it won't do anything, of course. So one more check. And the motor does nothing, which explains exactly why this here won't run. So that's a replacement. And this gets interesting because I just checked this motor on a pulse width modulation power supply, and it turns out that it runs perfectly. So that makes me wonder why this motor is not working in this situation, while it did work previously. So let me reconnect, and of course let me reconnect this motor as well. Right, and this one should be connected here. So, running again. That is one. And now for this motor. And now it runs. So that you can call some doubtful contact. Anyway, now all motors run again. So it is time to put the multimeter to frequencies again, because that is what it is all about. And let's see what happens when I measure the frequencies according to the approval recipe. And that is 420. Let me put the camera in a better position so you can watch. Once again on the minus, and once again in the probe, or in the green one, and it shows 450 to 500 Hertz. So let me measure. Oops, I have to be careful. So let me measure on this point. Which is over 1 kilo, also around 500k. So 500 Hertz. So somehow the circuits are not nice. Also, what is remarkable is that this motor always starts running automatically, while this motor is not. I have to give it a little, let's say, little push, like you see now, and now it runs again. So once again a check here, and this says around 1:30, and it's timed again that the contacts here on the from the power is getting disturbed a bit, so I really have to take care of that. Anyway, from here to here it's almost 130 Hertz. So the question is, why this not and why that is? Probably time for simulation. So in an attempt to simulate something, I have created in Scilab XCOS oscilloscope, then an electrical motor, a voltage sensor connected to ground, a resistor, which is for now the value of 4 resistors of the type that I use. So that should be alright. Then an AC frequency of 1 Hertz. Then a pulse generator with a pulse of 20% of the period. So 20% of 10 seconds and an amplitude of 7, but that is too much, so I will do that reduced to 5. So let me see if I can simulate something. And it says problem in port size or type, and that is supposedly here somewhere. It says 0.4 ohms, and this is the first time I do use a component of this toolbox set brushless DC machine. So I have no idea right now where to look. Of course I do know what this all means, but running this from an import size or type, which would mean that here is something wrong. So what I could do is using another one which has a similar idea, and this is just trying. Same problem, and then I'll figure that the rest has the problem as well. Well, last chance for now. Oh, this one can't be done because it has 3 openings. So I figure I have to do it like this. Then I would appreciate a simulation starting. Yes. So although a simulation starts, I'm not using this toolbox, which I wanted. So unfortunately I have to dive deeper into it. So that's up next. Okay, a little change in the diagram, in the schematics. I have replaced the resistor by a variable resistor, and that is being connected by the 1 volt 1 hertz AC and the voltage sensor, and it is being fed by this sine function. I can add a motor, a pulse width modulation. However, that takes some more study to get that done, so let me first try to get this working, or simulating anyway. So I'm very interested in what this brings. And then let's see what happens now. As far as I can see, not much. Implicit blocks. So let's see what this is. It has no variable, no value. This one has, but I have set it to an amplitude of 5 for the sine wave. One frequency is 1 hertz. 0 radials of the sine wave. Well, radials is different from degrees, of course. As you know, 180 is 1 pi. Am I correct? 90 is half pi. So how should I do this? Like in maybe this. The answer is the input is accepted, but does it work? So far, not really. You can, for example, include a dummy CLS block from the linear palette. So where is the linear palette? This is non-linear. It's interesting that they call a linear palette without saying where it is. because this is clearly non-linear. So this is actually interesting. How do I find something what I'm looking for? And there's no real indication where I should look at. Maybe the source, but I don't see it at all. So let me close this or stop it. See what it says again. Yeah, a dummy CLSS. I'll have to find it in order to have this working. As you can see, the simulation is running. I did not find a dummy CLSS block, but for some reason Scilab stopped suddenly, and after reloading it just works. Although just works is maybe a little bit overstatement, because I still have no motor in it. And if you look at all the blocks here, pre-actuators, actuators, a DC motor, has to be added somehow. So and considering these connection points, it can't be put here directly, which would be somehow possible with this, but here they are these are black, so that would be possible, but I'll have to find out how to exactly do it. I can do a test, a short one. So I stop the simulation. Let me just pick this one. And then I'll delete it. Oh, that's because it was still selected. And then from here, and that cannot be done. It must be connected to a command port. So let me just add it like this. Save to be sure, and go. Okay, see what happens, if anything. Problem in port size or type. So that is once again, so I'll delete this one once again, connect it, save, run. I'll ignore this. It runs for some reason. And the reason that I want the motor here is because in the real circuit I have no less than 3 motors behind a pot meter. The motor that I earlier should have to replace but works again is behind the pot meter, and the pot meter is nothing else than a variable resistor. And the other 2 motors that have a propeller are behind one as well. So, and now you see something else happening, a warning at the scope, and this is stopped. So I end this and I start again. See what's happening. Ignore, and there you go again, and it crashes. So Scilab has something that is not quite as nice. So let me just start again. Here Coselica auto loads, and I take Xcos. What I want to load is from here I want Xcos files, apparently not here. That's a very nice one. Are they here? No. So I have to find out how that is. Okay. Let's find. Okay, we're back with Scilab Xcos. The conclusion may be for now that there is apparently a maximum time of simulation, and after that it is prone to crashing. Why, I don't know. I still need to find out how I can insert a motor block here, so it really simulates a situation as I have in a real circuit. I have the choice between Coselica and XCPL. They have both different connectors, and since this comes from Coselica, it has some apart connectors, so I have to find that out. Also the way they are to be connected. An example showed that for example the Coselica blocks have or the XCPL, I have to say XCPL has some loop back functions, so from the exit there is a connection something like this. But once again, that is to be found out. In the meantime, let me run a simulation again. See if it is still willing to run. I will again ignore this, and there you go. So this is more or less exactly what I've been seeing, and with this, unfortunately, I cannot see the difference between a variable resistor and a non-variable resistor. Also, I now notice this going higher than 5, so let me check how this is situated. Amplitude of 5. Okay, how is this? This is as it was. This I can't find. There's no setting, probably because it's variable, but then again, what else? Nothing more except that this is going to be continued. With simulation, and then I'll try to see if I can get it more natural, because I'm not quite sure about these settings, although it gives a nice simulation. If I get this nicely, I still have to find out how to get
real frequency that I need for the French Technique motors in the range of 40 to 120 Hz on the real circuit. I may have to deal with some resistors at several places. Who knows? That is to be found out. So right now, thank you for watching, and if you like my videos, please subscribe to my YouTube if you haven't done it already. Please consider supporting my blog and videos by allowing advertisement in between the video segments. And if you don't like to do that, please visit my website, which is listed under the video, for another possibility to support it via PayPal. And this is to be continued.